let's get out our calculators, because we're going to, obviously, in the trigonometry unit, there's going to be a lot of things that we need our calculators for. Okay, so, anybody know what the word trigonometry even means? Triangle measurement. It means triangle measurement. So this is all about triangles. Now, what do we know about triangles? They have 3 sides and 3 angles. So today we're going to talk about angles. Now, you can all draw an angle, you can all measure an angle. Now, here's the kicker. When you measure an angle right now, probably, like if I said how big is this angle, you would say something like 38 degrees, right? Most of us measure our angles in degrees, but there are other ways to measure angles, and that's the first thing we want to talk about, because the farther you go in mathematics, the less you're going to use degrees. And here's why. Degrees are completely artificial. Can somebody define a degree for me? What is it? It's 1/360th of a revolution. Think about that for a minute now. Is that what a degree is? 1/360th of a revolution. Those crazy Egyptians were fascinated by 6s and 12s, and that's why there's 12 inches in a foot, 60 minutes in an hour. All those things date back to the Egyptians. When the really smart guys, like in the 1700s, started developing the calculus, they wanted a more mathematical way of talking about angles. Degrees are fine. We'll continue to use degrees, but we're transitioning to this new unit of measurement called the radian. Now, did you guys talk about radians at all last year? Okay. The radian is the measure, and you might want to write this down, the measure of the angle determined by striking an arc of radius length. Oh my gosh, she's going to make me memorize that. Oh my gosh. What does that mean? Well, it talks about a radius and an arc. So there must be a circle involved, right? So here's a circle, and let's just say the radius is 5 inches. If I were to take a piece of string, Jackie, paying attention, honey? Yeah. This is so cool. If I were to take a piece of string 5 units long and lay it around the circle, so an arc of radius length. So I just said my radius is going to be 5 inches. So I'm going to take a piece of string and lay it around the circle, an arc. Can you see that the end points of that arc determine an angle? And that would be 1 radian. So, what do you think would happen if I took my circle with a radius of 5? What do you think would happen if I struck a 5 and another 5? Then that angle would be how many radius?
2 radius.
2. Does that make sense to everybody? What about, let's do one more, and then you're going to develop a very, very important formula. What if I took my circle with a radius of 5, and I struck an arc 2.5 inches? How big would that angle be? Half a radian. other words, there's a relationship between the radius of the circle, the measure of the central angle, and the length of the arc. What's the relationship between the radius, the angle, and the arc? Can you see it? If the radius was 5 and the angle was 2, the arc was 10. If the radius was 5 and the angle was 1, the arc was 5. If the radius was 5 and the angle was 1/2, the arc was 2.5. So what can you tell me about angle, radius, and arc length? They multiply to get together. So in other words, the arc length is the radius times the radian measure of the angle. If you want to know how long your arc is, you're going to take your radius times your radian measure. So 5 times 2, and that gives you 10. Right? 5 times 1 gives me 5. 5 times 1/2 gives me 2.5. So if I were to make up a different situation, let's say the radius was 6 and the arc length was, let's say 20. So we'll say 6 inches, 20 inches. Could you tell me the measure of the angle? You could, because you know that arc length equals what? Arc length equals radius times the radian measure of the angle. So how big would that angle be? 26 or 10/3 radians. One more. Very important formula. Your book is going to write that formula. S equals r theta. This is the Greek letter theta. You've probably seen it on sororities or fraternities or something. It is one of the Greek letters. Trigonometry was developed by the Greeks, and it's one of the letters, the Greek letters, that's used to identify angles. We also use alpha and beta and gamma, but theta is probably the most common one. S is your book's letter for arc length. So arc length equals radius times angle. I remember it because it clicks in my brain better. Arc length equals radius times radians. That also reminds me that if I'm going to use this formula, my angle cannot be in degrees. We're going to do one in a minute. If it's in degrees, we got to change it to radians. So we're going to learn how to do that. But first, let's do another example. Let's suppose we have this situation. Our radius is 10 and our arc length is 18. Could you tell me how big the angle is? Oh, I just did one like that, didn't I? All right, well, we'll do this one and we'll do another one. How big would that angle be? 18 equals 10 theta. So theta equals 18/10 or 9/5 radians. Right? I've done two just like that. Be a little different here. How about if we know that the arc length is 23 and the angle is 1.4 radians, could you find the radius? Yes, because we know arc length equals radius times radians. So what would our radius be? 23 over 1.4? Whatever that is. 16.43, is that what you guys said? Now, one quick comment. If the arc length, it's a length, so it's going to have a unit like feet. If the arc length is in feet, then your radius would also be in feet. They match. Does that make sense to you? Okay. So, here is the next problem. What if we had this picture? So we know the radius is 10. We know the central angle, that's an angle at the center of the circle, is 60 degrees. And I want to know the arc length. Can I use that formula? Not unless I change my angle from degrees into radians. Now, were there times in chemistry class where something was given to you in inches and you need it in centimeters? Or something like that? And you simply changed it, right? You did a unit conversion. You got it changed. That's what we're going to do with our angles. If we got it in degrees and we'd rather have it in radians, then we're going to switch. And here's what you need to know to make that switch. 2 pi radians is 1 revolution. So in other words, all the way around the circle is 2 pi. Okay, all the way around the circle is 2 pi. Do I want to go all the way around the circle?
Nope.
I don't want to go a whole 360 degrees, right? So in other words, 2 pi radians would be 360 degrees. So if that were 360, I would change it to 2 pi. But it's not 360, it's a 6th of 360. Would you agree with that? So if 2 pi radians is 360, then a 6th of it would be how many radians? Pi over 3. A third pi, pi over 3. Now that wouldn't be so easy if that central angle were 47 degrees. Would you agree with me?
Yes.
So let me go ahead and finish this because you've used logic. I'm very impressed. Let's go ahead and finish the problem, and then I want to talk about what happens if it's 47 degrees. What am I going to do? Well, let's go back. The whole issue here was the central angle was in degrees, and we're using our formula that says arc length equals radius times radians. I couldn't do the problem in 60 degrees, so we figured out using our heads that 60 is a 6th of a revolution, so therefore it's a 6th of 2 pi, which is pi over 3. So now my arc length will be 10 times pi over 3, or 10 pi over 3. And if this is 10 centimeters, then this is going to be 10 pi over 3 centimeters. The arc length and the radius have the same unit. Now we got a whole weekend and a test day, and then probably a day off. Oh my gosh, and then it'll be Thanksgiving. Oh my gosh, do I even see you next Tuesday? Okay, so it's going to be like forever before we start talking about this again. So what am I going to expect you to remember, since it's going to be like 9 days before we talk about this again? What are we going to remember? We're going to remember this. We're going to remember this, which is the same as that. I just did it in degrees. And we're going to remember one more thing. Okay? we're going to remember how to change degree measures into radian measures and vice versa. So let's suppose we want to change 47 degrees into radians. Now, when it was 60, it was easy because 60 was a sixth of a revolution. So 90 would be easy because what's 90? A fourth of a revolution. 30 would be easy. It's a 12th of a revolution. Those are easy ones. Wacko numbers like 47, how are we going to handle that? Well, we're going to set up a proportion. And here's the proportion we're going to set up. Now let's talk about where all those numbers came from. Obviously the 47 is the problem. Does anybody have any thoughts on this?
It's half of it.
What?
Half. It's half of a revolution.
Yeah. If we know 2 pi is 360, doesn't it make sense that pi radians would be 180 degrees? So this ratio is 1, basically. Pi radians is 180 degrees. Just like you say 12 inches is 1 foot, these are the same, they match. These two match. Pi radians is 180 degrees. So what am I trying to figure out over here? Pi radians is 180 degrees. How many radians would be the same as 47 degrees? Does that make sense to you? So you cross multiply. 47 pi equals 180 x, and x will equal 47 pi over 180. So the radian measure of 47 degrees is 47 pi over 180. You are going to set this proportion up every time you want to change radians to degrees and vice versa. Now, does everybody understand why I put the 47 in the denominator? Because it's a degree. If you're going to say pi over 180, then this side has to be radian over degree, right? Now, somebody else might say 180 over pi. That's fine. If you do 180 over pi, then you'll have to do degree over radian, right? All right, so now you try one. Because remember, this is one of the things I'm going to expect you to remember. I'm not going to do a bunch more stuff, but I do want you to remember these key ideas. Yep.
Would you want us to divide 47 pi by 180?
No, you leave it just like this. So we want to change, let's say 100 degrees to radians. All right, so see if you can do that. On your paper, you're going to do exactly this. So you should be setting up a proportion. What's that proportion going to say? Pi is to 180 as x is to 100. So you get 100 pi over 180, which reduces to 5 pi over 9. Everybody get that? Can I try one more? Let's change 280 degrees to radians. 280 degrees, big angle. 14 pi over 9. Anybody match that? Okay. So now the question is, what happens when you go the other direction? There will be times, particularly when we're dealing with 30, 60, 90 triangles, that you'll want to change radian measures into degrees, because you know about 30, 60, 90 triangles, and if you don't, you're going to memorize it because it's on the back of that gold sheet. We didn't memorize pi over 3, pi over 6, pi over 2 triangles. We memorized 30, 60, 90. So sometimes it's just more comfortable for us to be in degrees. So what if I said change pi over 5 into degrees? Could you do that? Could we use the same proportion? So we could say pi is to 180 as what now? Be careful. Pi over 5 is to x. Remember, that's a radian, that's a degree. So you need a radian over a degree over here. What's 180 divided by 5? 36. What's going to happen to those pi's? They're gone. So you got 36 degrees. Now that will always work. That will always work. I'm going to show you a shortcut. This will always work. If this makes sense to you, that this is the way I want you to do the problem. This is a very important skill. You've got to be able to do this. So if that makes sense to you, then that's what you're going to do. I'd like to go back just a minute and think about this. What did I tell you about pi? What are you going to remember? Pi radians is what? Not 1. It's a half a revolution, so it's how many degrees?
180.
180. So pi radians is 180. This is a fifth of pi. So if pi radians is 180, then a fifth of a pi would be 36. So you can go straight there without doing all of that work if you remember pi is 180. So if I had 2 pi over 3, pi is 180, right? So 2 pi would be 360, and a third of that would be 120. So you can convert these more quickly as long as you remember pi is 180, or 2 pi is 360, either way. Okay, so one more. How about 7 pi over 6? How many degrees is 7 pi over 6 radians? Okay, what's pi? 180. What's a sixth of that? 30. Right? 180. A sixth of it would be 30. Times 7 would be 210. That's 210 degrees. How about 2 radians? Oh, we got a problem, don't we? We can't use our shortcut. Why not? We're missing a pi. We're missing a pi. Oh, crud. What do we do then? What do we have to fall back on? Pi over 180 equals 2 over x. So pi x equals 360, and somebody said it, 360 divided by pi. So how many degrees is 2 radians? 360 divided by pi. All right? Okay, we're gonna do a quick little, like, quizzy type thing, but not for grade, just for practice. But these are the things I expect you to be able to remember. Okay? So here we go. Number 1, find the length of the arc determined by an angle of pi over 7 radians in a circle with a radius of 10 feet. It took way longer to write the problem than it does to do it. Okay, here are our 3 problems. This is what we're going to remember. Put stars by them or something, so that when you walk into class again in 9 days, or however and not long it is, till we talk about this again, you'll say, oh yeah, I remember that. Okay, so here's my scenario. I got a radius of 10, I got an angle of pi over 7, and I need my arc length. What's my formula? Arc length equals radius, that's 10, times radians, that's pi over 7. So 10 pi over 7 feet.
Yeah.
You should set it up the other way, because I use different.
Did you get 10 pi over 7? Then you're good.
I didn't know if it worked.
If it works for this one, it probably does. I'm not sure how you set it up, but it's good. All right, here we go. Change 80 degrees into radians. Pi over 180, very good, Griffin, equals x over 80. So x equals 80 pi over 180. Did I already do this one? 4 pi over 9. And the last one, and then I'll let you escape. Change 5 pi over 4 radians into degrees. If you want to use the shortcut, this is the kind you can use the shortcut on. What's pi? 180 divided by 4. 45 times 5. 225. So it's 225 degrees. If you are uncomfortable with that, you can set up a proportion just like this, right? And solve it. And you will get exactly the same answer. Okay, Maggie, will you put this off over there? All right, people, next time I see you.